minutes, 3 minutes late. Sorry about that. Okay. Let's begin then. Guys, by the way, before we continue with the sessions, I have posted an assignment for you. There are lots of questions in there. Please do as many of them as you can. Okay, and the deadline is going to be for Wednesday. Sure?
Okay.
Awesome. There are many questions, but try to do as far as you can. And the deadline for it is going to be Wednesday midnight. And please ask any questions in the process. If you have some problems with some of the exercises, let me know and ask them in advance. Okay?
Okay.
Awesome. Okay, let's begin. Let me slide down. And we continue with the logarithmic function. Hopefully today is going to be the last day that we are talking about the logarithmic function. Then we are just going to move on Monday to different topics and new topics then. But guys, any questions so far?
No.
No, everything is fine?
Yes.
Awesome. Okay, we talked about the properties, we talked about the logarithms, we talked about the natural functions, and now we talked about how to simplify this stuff, and we talked about the change of the base, correct? And now it seems that we covered most of the things that we were planning to do on I should say, the logarithms then. Then today, we are going to cover as a final touch on the logarithmic functions on the, I should say, let me see, we have still a lot on the exponent function. Then I hope that by next week, we just start by the trigonometric function. Then let's see how far we can go today, guys, with the concepts of the logarithm and exponential function, because the lessons which we have for today is spectacular. It's one of my favorite topics then. Okay, now guys, when we talk about the logarithmic functions, let me bring my own stuff here. Okay. Okay. Guys, the thing which we are going to do today is that we are going to talk about two very important things. We are going to talk about the logarithmic equation . Then tonight by 6 to 10, we talk about the exponential equation. Okay, when we talk about the logarithmic equation, what do we mean? But before, I'm gonna, I should say, because something is very important now, is that, guys, by the way, I was thinking that if it's going to be convenient for you, I'm going to also talk about that with Mo. But I was saying that maybe if you can have your camera on, it makes the class more interactive, and you can still be more focused. I'm going to talk about that with Mo on Monday. Maybe I have to ask you, please, when you're in the class, to have your camera on, that the class is going to be more interactive, and you see the other classmates and you get more involved. But let's see what happens then. But if you remember, guys, the thing that we covered, I should say, last week so far, was that we said that if you have a base, and the base of the function is getting an exponent, we call the exponents x. then it becomes equal to, let's say, for example, f of x, which it was your function. We said that if you remember from all the things which we have covered so far, we said that we can do in somehow a very interesting way. We said that we can have a different representation. We say that we can write it as, we say that the log of f of x with respect to the b which we had, we said that it's going to become what? It becomes what, guys? Do you remember that? Hello? It gives you the exponent, huh? That's what we covered so far. We said that now then, when we talk about the exponential function, we can talk at the same time with a logarithmic function because they are both sides of one coin. You can move from exponential representation of function f of x to its logarithmic representation, or vice versa. You can move from a logarithmic representation of the function f of x to its exponential representation. Guys, these mutual transformations is incredibly important when you work with the exponential functions and the logarithmic functions, correct?
Yes.
Yes? Please always remember this. Whenever you just want to work in functions grade 11 or advanced functions grade 12, always remember that you can close your eyes and write the same thing as I did. And make sure that you can move between these two different representations easily. You can move from this side to the logarithmic representation, or when you have a logarithmic representation of function f of x, you can move readily back to its exponential representation. How is that going to help us? For example, I'm going to ask you for this one very interesting question. You see how this transformation between these two images is going to be very important. Guys, for example, look at this. I say, for example, look at this one. I say the log of 2x plus 5 equals to what? Equals to, let's say, equals to 2. Okay, and you know from whatever we have covered so far, guys, you know that if you do not, when you have a log function, if you do not mention the base, from now on till next 100 years, you do anything in science, economy, finance, engineering, you know that the base is going to be how much?
10.
That's so true. The base is going to be 10 if you do not specify that. Look at this one now. I have this logarithmic representation of my function. The main driver of my function, it includes x. X, it reminds of what? Reminds of something unknown, a quantity that you have to figure this out, that how much is that going to be, correct? Then we can look at this one as a logarithmic equation. Because as the main driver of our function, it includes x. And x represents something which you do not know its identity. It's like, have you watched the movie Zorro? He was wearing a mask on the face.
Yes.
Yes? X is going to be the Zorro. It's the identity of that person is not identified. You do not know him. Then because Zorro is in the main driver, in the main seat of your Lamborghini, we call this exponential equation. Exponential equation means what? It means that you have to come up with a strategy to figure this out. How much is going to be the x? Or who is behind the Zorro mask? Huh? Correct? No, yes?
Yes.
Awesome.
Yes.
Now, guys, in order to find how much is the x, the first step is that I can just look at this function. It is a logarithmic representation, correct? It's a logarithmic representations of my function. In order to solve it, I see the best way is that to transform it into a exponential representation. That's why I was emphasizing so hard on that at the beginning, that these two representations are two mutual transformation. Means that from the log representation, you can end up easily to the exponential, and from exponential representation, you can end up easily to the log representation. In order to do that, I'm gonna write the log exponential representation of this function. What is that representation, guys? You know, this is your Lamborghini car. You start from the back seat, correct? Then, everyone sees this? You start from the back seat. You start from the passenger seat. You jump to the back seat. Then from the back seat, you jump to the main driver's seat, which is what? 2x plus 5, right?
Yes.
Any questions, guys, so far on this very interesting topic? How did I make the transformation?
No.
No? Guys, then you see that here, that very easily, I was able to do what? I was able to move from the log transformation, from the log representation to an exponential representation. Clear? Then now the question is that how much is the x? Then now it is much easier to solve it because this time I have something like the general algebraic representation of my function. How? Becomes very easy. How much is 10 to the power 2, the right side?
100.
100 equals to what? The right side, 2x plus 5, correct?
Yes.
Then the thing which I have learned is that when I want to solve this equation, I isolate the terms which they include my unknown, my zero mask function, one side, and I keep all the thing which is known to the other side. It means that I can keep 2x at one side, take 5 to the other side, becomes 100 minus 5, becomes how much? 95, correct?
Yes.
Right, guys? Then how much is gonna be the x? 95 divided by 2. Because I divided both sides by the coefficient of the unknown function. You see this?
Yes.
Then you see, guys, when you have a log equation, logarithmic equation, sometimes the best way to deal with that is you readily transform it to an exponential representation based on the definition which we had. Correct? That was the main purpose of this example. Any questions?
No.
Sir, where did 100 come from?
Where what?
Where did 100 come from?
100, look at this one. I said if that's the log representation, if I want to transform it into the exponential representation, I say the 10 to the power 2 equals 2x plus 5. 10 power 2 becomes what? 10 times 10 becomes how much? 10 times 10?
100.
100. Then I have 2x plus 5, which is the main driver of the Lamborghini car. Then from there, it's going to be very explicit. You can get the x. How much is that?
Okay.
Yes, Philip?
Yeah, is it
Next.
10? I can't see the paper very clear.
Which part?
The orange part.
Oh, this one? Oh,
Yeah.
oh.
Yes.
The orange means that this is not a good color then to use.
Oh, okay.
Is it
Now I
good
see.
now?
Yes.
Awesome. then thanks for saying that, because it tells me orange is not a good color to use it. Guys, any questions? Nothing?
No.
Nothing.
No, that's great. Then if there is no questions, I had a question for you. Ready? Let me find a good question for you guys. I'm sure that you are very excited to find a question, huh? Let me give you this. Okay. Guys, please solve this equation, which is this one. 3 log x plus 4 plus 7 equals to 13. Ah, beautiful one, huh? Guys, please spend 2 minutes, 3 minutes on this. Then we share our ideas together to see how to deal with this beautiful equation. Everyone can see the equation?
Yes.
Yeah, great. We share together. We share it. Guys, are you done now? Can we do that together? Who's done? No one? Ferris?
No.
Gloria?
Not yet.
Philip?
No.
Rose?
Almost.
Almost. Good. We take 1 more minute, huh? Guys, shall we do that together?
Yes.
Yeah? Okay. Okay, I'm gonna look at this equation. And when I look at this equation, what do I see? I see a log function, which very interestingly, the unknown, which is x as a 0, is inside of the log function. It seems that the 0 is inside the Lamborghini car as a main driver. We have to ask him to step away from the car to identify him. Okay, the first thing which I'm going to do, guys, always remember, the best thing is that put the log functions into one side, look at this. It's always good that to keep the log functions into one side and all the non-quantities to the other side, huh? Yes? But if I want to do that, I see what are my non-quantities, guys? 13 and 7, huh? That's right?
Yes.
Yes, guys?
Yes.
Then the thing which I can do is this. I say 3 times the log of x plus 4 equals to what? 13. I take the 7 to the other side, huh? It becomes minus 7, correct? Minus 7. Right, guys?
Yes.
Fantastic,
Yes.
fantastic. Then, at this stage, what are we going to do? I see I can take the 13 as the next step. I see 13 minus 7. How much is that?
6.
6. Then I have 3 log of x plus 4 becomes 6. Correct?
Yes.
Fantastic. And now, what can we do? We see, guys, we have 3 times log of something is 6. Is it possible, as long as 3 is not 0, I divide both sides by 3? Yes?
Yes.
Can I do that?
Yes.
Yeah? If I divide both sides of the equation by 3, what do I end up with? Log x plus 4 equals to 6 divided by 3 becomes how much?
2.
2. There, that's the best form to transform it into the exponential function. Let me highlight this. I love this format, that you have only one log functions into one side, and you have non-quantities on the other side. Guys, then you see that from here, we ended up to here by some basic elementary algebraic manipulation, which it was taking 7 to the other side and divide both sides by 3. Any questions, guys, so far?
No.
No?
No.
Rose? Philip?
No.
Faris?
No.
No. Great. And now, the guys, the question is that, what is the base of this logarithm?
10.
10. I'm going to write it with the color which is visible. It is 10. Because I know that if log base is not written, it says that I'm 10. We do not write it for convenience. Okay. Now this one, guys, it is a log function. I want to represent it into an exponential format. Correct? I'm going to write it into exponential representation. I have the log function going into the exponential representation. That's where it's going to happen right now. How is that going to happen? I'm going to say what? I have a Lamborghini car. I jump in from the passenger seat. What is a passenger seat?
10.
10, which is my base. I move to the back seat. What is a back seat?
2.
2 equals to what? The main driver's seat. X plus 4. Yes, so far so good?
Yes.
Great. Then, guys, it's getting very easy. We learned it a year ago. How to solve this? First of all, 100 to the power 2 becomes how much? 10 to the power 2.
100.
100 equals to x plus 4. Ah, guys, it's gonna get very hard. It's so tough right now. I can't continue. How much is the x now? This equation, how much is x?
96.
That's right. You take 4, go to the other side in order to isolate x. Becomes 96. Right?
Yes.
Beautiful, huh? I love these kind of equations. Guys, any questions whatsoever from here to here? Any questions?
No.
Rose, was it
No.
you? Philip? Faris? Gloria?
No.
No? You see, by simple algebraic manipulation, you end up to this, and from this, you change it to representation into exponential representation. Then from there, things are very easy. Okay. It's going to be April 3rd, 2020. It's going to be functions 11. It's going to be page number 1. It's going to be page number 2. Okay. Shall we move on, guys? Any questions?
No.
No? Okay. I'm going to give you one more example. Then we move on. Let me see. I'm going to give you, let me see. I'm going to give you this one. I'm going to give you the ln of x squared plus 4x equals to 1. Ah, so good. This one is so good, guys. It's so relaxing. Okay, guys, please try this one. But I have to remind you before you move on, do you remember what is ln? Who remembers that?
It's log E.
That's right. If you remember that, guys, normally we have two favorite log functions. One of them is the log. If you choose its base to be 10, the other one is the log. If you choose its base to be equal to e, and we saw that e equals to what? 2.71. If we write log with the base e, we write it as ln. But if you have log with base 10, we write it as only log. These are two very artistic, I call that artistic way to show these logs with these two popular bases, base 10 and base e. With base e, it becomes ln. With base 10, you simply write log. And going and say that, please try this one. Guys, are you done now?
Not yet.
Guys, shall we move on? Yeah?
Yes.
Let's see, who's done now? Okay. Nobody finished it? No?
Not yet.
Not yet. Let's do that together. Guys, when I'm just gonna move it here, we are gonna do that in two formats. The first thing is here, guys, when I have this one, I know that ln, I can write it as the log, which its base is interestingly e, the natural number, which also comes with the x squared plus 4x equals to 1. How do I have it as an exponential representation? I know it's going to be very easy. Why? Because I say that in that case, e to the power 1, which is e itself, should equals to x squared plus 4x. Correct? So far, so good. Everyone so far is okay with that?
Yes.
Yes? And now, guys, what is this? This is a simple exponential function, so simple quadratic function, which we covered that on the first day of the class. You remember it? We said that when it comes to this stage, what do we say? We say that, okay, I can write it in this format, say x squared plus 4x minus e equals to 0. And I write it e because if you remember from previous session, we said that e plays the role as a constant in the math. For example, like the pi, which is 3.14, we have e, which is 2.71. Yes, guys? Then, essentially, we were able to represent the log functions which we had into this. Correct? Then these log functions with the base of a natural number is reduced to this quadratic equation. Guys, you see how beautiful is that transformation? Yes?
Yes.
You see how beautifully you transform the functions from this as a logarithmic function to just a quadratic function. And when you are there, it's very easy to find the answer. X is going to be what? You have a formula for it as a detriment of this. You say it's going to be 2 times of the coefficients of the x squared, because 2 times 1 becomes what? 2. You have minus of the coefficients of the x becomes minus 4, plus and minus of the square root of b squared, which is 16, minus 4 times e becomes plus 4. And let me write the natural number like that. So far, so good. Yes, everyone. Any questions so far?
No.
No.
Rose?
No.
Philip?
No.
Gloria?
No.
And Ferris? Ferris?
No.
Awesome. Awesome. Now we are at this stage. The problem, guys, is that we have the e inside the square root. We have the times, it becomes very messy. We keep it very easy like that. We say our x is going to be either of these numbers. We do not continue that. Huh? Yes? We are fine at this stage. We do not continue. We say x is either minus 4 plus this square bracket divided by 2, or x is minus 4 minus this square root divided by 2. We finish it at this stage, and that's why I'm going to grab my black marker, put a dot sign there to say that, okay, I'm done. I do not continue that further. So far, so good?
Yes.
And now,
Yes.
guys, I'm going to give you the very last example. Then we should be done for this type of the examples of the log functions. I'm going to give you guys this beautiful function. I'm going to give you the log of x squared plus 4x, the same functions which we had before. I change the base to number pi. Pi, how much is pi, guys?
3.14.
That's so true. Should equal to what? Equal to 0. Oh, beautiful, beautiful example. Guys, you have to give the answer in a second. How much? Please solve this equation. Example. Oh, beautiful function. X squared plus 4x. Base is going to be pi. As Rose said, it's 3.14 and 15 at the end. 3.14 equals to 0. Oh my God, I love this function. You see, please take note that the base is very irregular. Normally, we do not have the base, which is going to be pi. Okay, guys, are you done?
Yes.
Rose is done. Who else? Gloria,
Not yet.
Ferris, Philip.
Almost.
Almost. Good. The word almost is very promising. It means that I'm there almost. A promising word to use. Give 30 seconds, then you do that together. Okay, I continue. Let's see. Let's do that together. Guys, before even I transform it into logarithmic function to let's say the exponential function, you can do that in two different ways. First of all, as a side note, as a property number one of the log functions, guys, you learn that the log of f of x with any base b then equals to 0, it means what? It means f of x is what? Equals to 1. That's the side note. It was essentially property number one that we learned it a couple of days ago, that we said that the log of any function with any base, regardless if the base is pi, e, anything, when it becomes 0, it means that the function is equal to 1 itself. It's very easy, and if you remember, in order to prove this, we had to write what? We had to write the exponential representation. We said that x squared plus 4x equals to pi to the power what? Hello?
Over 0.
Power 0, that's right. Pi to the power 0 ends up there. What is pi to the power 0, guys?
1.
That's so true, and essentially that's this note. But I got to the same note when I transferred my logarithmic representation of the function into the exponential representation, which it means that the x squared plus 4x equals to 1. 1 because pi, I know it becomes 1 because I know that pi in parentheses pi to the power 0 becomes 1. Then I have this equation. Then again, I ended up with this transformation into the quadratic equation, which it means what is that equation? X squared plus 4x minus 1 equals to 0. Correct? Then you see, guys, that with one simple representation, transformation in the representations which I had, from the logarithmic representation, I was able to end up in a more favorable representation, which is now the exponential format. Clear? Yes? Now, the thing is that, guys, now, how to solve this? It's not hard, huh? Because we know that the x equals to this formula. In solving, I should say, a quadratic representation. At the denominator, I have what? 2 times of the coefficient of the x squared. How much does that become? 2 times 1 becomes 2. I have minus of the coefficient of the x, which is minus 4, plus and minus square root of what? 4 squared becomes 16, minus 4 times 1 times minus 1 becomes plus 4, huh? Right? Then as a result, x equals to what? Anyone?
And
Minus 2. I divide. Yes, yes, please go on, Rose.
minus 2 plus or minus square root of 20 over 2.
That's so true. And that's thanks, Rose. Thank you. And you see that, guys? It becomes very easy now when you get to this stage. I hope that right now, as we are just going to our first break, you learned it, guys, by simply changing the representation of the logarithmic to exponential, or exponential to the logarithmic representation, how life becomes very easy. For example, when you have a logarithmic function, if you change your representation to an exponential function, you end up, instead of solving a logarithmic function, you end up to solve an easy quadratic function. Any questions, guys?
No.
No? Rose?
No.
Philip?
No.
And Ferris?
No.
No, awesome. Then guys, please take a 15 minutes break. When we come back, I introduce to you another type of logarithmic equation, which they involve more work because you have to use different properties out of those 7 properties that you learned to solve the logarithmic equation. Please take 15 minutes break. Please come back by, I should say, 12:16. We continue by then. Okay,
Okay.
awesome. Enjoy your break. See you in 15 minutes. Hello. Everyone is back?
Yes.
Awesome. Okay. Only Rose is back? Yes? Gloria, Ferris, Philip?
Yes.
Oh, you're back all, huh?
Yes.
Mhm.
Awesome. Okay, guys, let's continue. Okay, let me see. Okay. Okay, now just let me go to the second type of, it's gonna be page number, what page number is that? 1, 2. It's gonna be page number 3. It's gonna be page number 4. We move on. Guys, the second type of the logarithmic equation that we're gonna work with that today is this one. We have a kind of a 4-step strategy for it. They are not as easy as the one that you could simply change the representation into an exponential representation to solve it. These ones, they require more steps to be taken, but still they are very easy, but they have more preparation. For example, look at this function. We say that the log of x equals to 1 minus log of x minus 3, and I choose the base to become 4. Huh? Okay, let's do this as page number 5, and I put that as an example. Everyone sees this equation? Okay. Guys, for this type of equation, when you want to solve them, and you see that they are not like the other ones. For example, on the previous examples which we had, always it's like that. You have, let me get another one. You see that, for example, you have the log function, and that's it. Then you end up with some non-quantity. There's only one log function. But look at this one. This one, you see that you have 2 log functions, which one of them is x, the other one is x minus 3. And we are so lucky that the bases are the same. If the bases are not the same, that you have to make them the same based on property number 7 that you learned a couple of days ago. Now we are so fortunate, the bases are the same, but the problem is that we have 2 log functions. If that's going to be the case, we have 3 steps to take. The first step is what? The first step is, for example, like the class, that, for example, you seat all the girls to one side of the classroom and all the boys to the other side of the classroom. That's what we're going to do. We are going to put all the log functions to one side of the equality and all non-log functions to the other side. What are my log functions, guys, here? One of them is log x, correct? The base is 4. The other one is log x minus 3. True, correct? I'm going to take it to the left side of the equality because the plan is that to take all of them at one side. Then if I do that, I end up with this. It becomes the log of x minus 3. Philip, do you see the green color? Is it better than the orange, huh?
Yes.
Awesome. Still the same base as 4. What do I end up with? Equals to, I have a non-quantity, which is what? Which is 1, correct? I keep it to the right side. So far, so good, guys?
Yes.
Yes? Then step number 1, I took all the log functions to one side and I kept the non-quantity one side. I call this one step 1. For the step number 2, always, without any exceptions, involves that you use property number 5 or property number 6 of the log functions that you learned a couple of days ago. Which property is going to be relevant, guys, at the left side of the equation? 5 or 6? That's why I have given you lots of homework, because it helps you to remember some stuff. I'm going to write a note here. This is note, just not part of this equation. I'm going to write note. And in the note, I'm going to write this. Guys, we said that for property number 5, we said that the log of A times B, which AB are two different functions with any base, should equal to what? Should equal to the log of A plus the log of B. Do you remember that? Property number 5. We said that if we have two drivers at the Lamborghini car, they are fighting over who is going to drive the car. We give each one the Lamborghini. Do you remember that?
Yes.
Yes, it was property number 5, correct? Oh, not this marker. This one is almost dead. For this one, I was telling that it's going to be property number 5, correct? I'm going to use this property applied to this log function. That is going to be my plan. It means that I'm going to take this one from here, bring it here. Okay, then that's going to be the strategy. If I use this strategy, guys, what's going to happen to my main equation? I'm moving from property number 5 from right to left. I have two log functions summed. It becomes to one log function, which is the product. That means that they are multiplied. Does it make sense, guys? Do you see this? Then becomes x times x minus 2. I can have an echo of my voice. Okay, does it make sense?
Yes.
Base 4 equals to what? Again, the same number, which is 1. Any questions, guys?
No.
No.
No? Philip? Philip?
No, I said.
Ferris? Gloria?
No.
Okay. And now, from this stage, it becomes the next one. Now we got back to the lesson which we had before we go for the break. We have only one log function on the left, and we have a known quantity on the right, which is exactly what we did before the break. We can transform this log representation to an exponential representation. Huh? It means that if my base is what? My base is how much? 4.
4.
It means that I can keep the base where it is, 4. I go to the backseat drive. What is the power? 1 equals to what? X times x minus 3, right? Then, as a final step, I can expand this one to this. I get x squared minus 3x, and take 4 to the other side. 4 minus 4 equals to 0. You see this, guys? Again, we ended up with simple quadratic function, which we are so good to solve it. Am I right?
Yes.
Then you see, guys, to catch up with what we did so far was that from this one, we isolated every term which they involved logarithm into one side. I use property number 5 in this case. Sometimes you have to do property number 6 to end up with one log function. Then from the same log functions which I had here, I use the exponential representation to get from here to this. Then from this, I end up with a function which I know easily to solve it. That's quadratic function. Do you know how to solve the quadratic function, guys?
Yes.
Yes, everyone? Sure, that's the easiest one. Guys, any questions so far?
No.
Gloria?
No.
Philip? Ferris? Okay. Then we'll leave it at this stage. I leave it as a homework for you to continue with this one, find how much is the x, because that's the easy thing. Okay, guys? From this one, you can easily find the x. Okay, let's do one more example, then I assign you some extra stuff to do. It's going to be our page number, what? 6. Let me find you a good example. Guys, I got a very good one for you. Put that as an example. The function is going to be log x plus 12 minus log x equals to log x plus 9. Guys, do you see the good quality of the thing which I have written? It's log x plus 12 minus log x equals to log x plus 9. Huh? And you see that I have x at every logarithm there. Please give it a couple of minutes to see if you can solve this equation. Okay?
Okay.
Awesome.
Okay.
Thank you. Guys, before you start, by the way, in any other classes which you have, do they use the same strategy? Do they write it on a paper and you see it from the camera, or no, they do different stuff?
No.
They do different stuff, huh?
Yeah.
Mhm.
But not on the paper.
No.
What do? They write on the whiteboard on the software, or how it works for them?
The for my business class, they use PowerPoint.
Uh-huh.
Yes.
Uh-huh. Okay, PowerPoint. Any other idea that you got from the other classes?
Yes.
What, Gloria?
Oh, I have the science class.
Sorry, what?
Science.
What do they do?
My teacher use her PowerPoint and
Oh,
use
PowerPoint.
sociology.
PowerPoint, huh?
Yes.
Uh-huh. Okay, interesting, interesting. Nice. Yeah, but for math, I think that's the best way to just write it on a paper. Otherwise, it becomes so hard. I wish if I had better technology that you have a better view of the thing which I write, hopefully I can buy some good quality stuff. Okay, I give you 2 or 3 minutes to see what do you do with this. But please ask me any questions if you need some help at any stage. Guys, are you done? Hello?
Yes.
Are you done, Rose?
Yes.
Oh, great. Okay, now let's see. Anybody else? Philip, Ferris, Gloria,
Yes.
are you done?
Sir, can I go grab my lunch?
Yeah, sure, please. Ferris and Gloria, are you done?
Almost.
Almost. Almost is a promising word to use. Okay, let me continue, then you can catch up with me anywhere in between. I'm going to solve it with two different methods. The first method, guy, is going to be very cool because I do not look to the other side. I see a log functions to the right side, which is log of x plus 9, correct? I'm gonna say, okay guys, it starts from whatever you have on the left. Okay? On the left, what do I have? I have log of x plus 12 minus log of x. You see, I have a minus between these two logarithms. What property does it remind you of? Huh?
Property.
Huh? What, Rose?
Property 6.
That's so true. What was property number 6? I put it as a small note before we move on. As a kind of a note, I write it property number 6. What did we have? We had the log of A divided by B was equal to what? The log A minus log B, correct? Okay, now, like we had these ones before. But I look at this, it was property number 6. Property number 6. When I look at this one, I get the same clue. I say, okay, I'm just gonna write the left side like this. Then I say it's gonna be the log of. What do I have to write, guys? It should be a ratio. The numerator is what? The numerator is my first function, correct? Which is x plus 12. Yes, guys?
Yes.
What is the denominator of the unified log function?
X.
X. True. Then it equals to what? The log to the other side, right? Log of x plus 9. Correct, guys?
Yes.
Yes. I'm going to write this one method number 1. Method 1. In method 1, guys, you will see that I use property number 6 to just for those two logarithms on the left to make them into one logarithm function. And I see I have two logarithms which their bases are equal, correct? Because how much is the base there?
10.
10. The base is 10. Then I see that if I'm at that stage, I can conclude something, which is gonna be a note. My note is this. I'm telling you guys, if the log of a function, I call that f of x, with base b equals to the log of another function, I call that g of x, but the bases are the same, I say that, okay, in that case, f of x should equal to g of x. You see what happened there? Yes?
Yes.
I say that, okay, let me isolate the notes which I have written here, that I do not confuse it with whatever I have written on the top. I say as a note that if I have log on two sides of the equality, which I am so careful, guys, I am extremely careful that the bases of these two log functions are the same. If this is 10, the other one should be 10. If this is whatever, that thing should be that whatever. Huh? But they have different drivers. I see that if the bases are the same, then I can deduce that those two functions, f of x and g of x, are also the same. Make sense to everyone?
Yes.
Yes?
Yes.
Then as a result, I have the same problem here. I have two logs from both sides of the equality, but I have different drivers, then easily I can say x plus 12 divided by the x should equal to x plus 9. Correct? Then what's going to happen next? Then I said x plus 12 divided by x should be equal to x plus 9 based on the theorem that we learned. Then as a result, in order to solve it, I multiply both sides to x. Then I have what? From this, I end up here. I have x plus 12 equals to x times x plus 9. Right, guys?
Yes.
Guys, what time is it? I'm too slow today.
12:40.
Okay, I'm too slow today. Okay, then what we end up with? We say that, okay, this is the page number, not that anything. From here, you see this, guys?
Yes.
From x plus 12, if this is going to be x times x plus 9, now it's very easy to solve it. How? I say I have x plus 12 on the left side equals to, I expand x to each terms inside the parentheses on the right side, x squared plus 9x. Then you see that we are getting so close to our popular form of a quadratic function, which is going to be x squared. I take x to the other side, becomes minus x, then I get plus 8x. Then I get 12 to the other side, becomes minus 12, equal to 0. Correct? Everyone got the same thing?
Yes.
Rose, you got the same thing?
Yes.
Awesome. How about you, Gloria?
Yes.
Great. How about you, Philip?
Sure.
You got the same thing, or it's a little bit different?
Same thing.
The same thing. Awesome. How about you, Ferris? Ferris? Okay. Guys, the method number 2 was like that. Look at that. For this method, I just got this one. But another method which you could have used, it got to the same result, was that you could have taken the other log to the right, to the left side to make the right side equal to 0, then use again property number 6. Who did that method?
Me.
Who?
Rose.
Rose. Yeah, you see both of them are equivalent. Then
Yes.
either you can stay there, use this theorem, Rose, to say that because two logs share the same base, I said that the main drivers are equal, or you can take it all to the other side, then decide, okay, use property number 6 again, then end up to the same result. That's right?
Yes.
Awesome. And you please, guys, as a homework, solve this quadratic equation yourself, because that's the thing which you are so good at it, huh? To see how much the x is going to be. Okay. It's 12:44. Let's see. Any questions, guys?
No.
No? Okay. I'm going to give you 2 exercises now. It's going to be our last example for today. You solve it, then the class should be finished. I called that as another example. As another example, guys, I'm just going to give you this equation. which is going to be the log of x plus 8 plus the log of x equals to log of x plus 18. Okay. This is going to be our last example for today. Then we do that, we should be done. Guys, let's see what do you do. Ready to solve it?
Yes.
Fantastic. Guys, are you done now?
Yes.
Yes, fantastic. Okay, Gloria, how about you?
Almost.
Almost. Almost is a promising word to use it always. Means positive. How about you, Philip?
No.
Not yet? No worries. How about you, Ferris? Okay. Now, okay, let's do that together, guys. Let's do this together and see what happens. Guys, from this, it's going to be something, guys, please, whoever is not done, please follow us along and you help me to solve this when you complete also your notes. Guys, from these two functions, when I look at the left side, which is going to be these two log functions, what property out of those 7 properties which I used, I can use in order to simplify that left side of the equation? Each property.
Property 5.
Property number 5, correct. Property number 5 says that I can, if I want to move from right to left from that property, I can say that if I have two Lamborghini cars, which they have to share the same base, because here the base is 10, the base is 10. If they have the same base, I can put them inside one Lamborghini car, which it has the same base 10, but multiply the drivers together, means x times x plus 8, correct? Yes, everyone is fine? Philip,
Yes.
Gloria, Ferris.
Yes.
Ferris,
Yes.
how about you, man? Sorry, what? Somebody said something?
No.
No? Ferris, are you okay so far? Then it becomes the log to the right side. I know the right side, what was the base of the log in the right side?
10.
10, so correct. Then I have the same base 10. What is the right side? It's essentially x plus 18. Guys, from this stage, you have two methods that you can use. Either you take this log on the right to the left and use property number 6, or you can use that theorem which we talked. You say that because from both sides of the equality sign, I have two logarithmic functions which they have the same base, then I can say these two should be equal. Huh? Previously, I used that method. Now I'm just gonna do the first method to take the other ones to the left side and follow from there. Because the previous example, I used that theorem. But you can do this at this stage. You say x times x plus 8 equals x plus 18. Because these two logs share the same base, then these two arguments should be equally the same. Yes, correct, guys? Is it obvious?
Yes.
Yes? Now, I'm going to use the other method. I'm going to use from this, I'm going to apply the other method. I'm going to say the log of x times x plus 8 equals to, no, y equal minus log of x plus 18 equals to what?
0.
So true, 0. I know that the base is what? Still 10. Let me, okay. Then guys, from here, I can still use property, which property?
6.
6, because they are minus together. Then I'm going to write it on the next page. Then I'm going to, what happens to that? Again, by using property number 6, I know that I have to write the log. What is the numerator of the log argument? Becomes the first function, huh? X times x plus 8, correct? X plus 8. And the denominator of the main argument becomes the second function who comes after the minus sign, which is x plus 18, right?
Yes.
Times x plus 18 equals to what? Equals to 0, because I use property number 6 to compact them together. How much is the base?
10.
10. Correct. And now, guys, at this stage, I got back again to the same thing that we learned it before going to the break. We end up with a function, logarithmic equation, that the right side is a known quantity, which is 0, no arguments of the x, and I know the base, I can transform the representation into exponential format, correct? Yes, you remember how did we do that before?
Yes.
Which it means that I want to go to drive the Lamborghini, but I take the hard way to do that. I go from the passenger seat. The passenger seat is 10, the base of the logarithm. Oh, I forgot the orange is not a good clear. I go from the passenger seat, which is 10, go to the back seat, which is power 10, 0, equals to what? To the main driver argument, which is x times x plus 8 divided by x plus 18. Correct, guys? You see what happens?
Yes.
Yes? But what is 10 to the power 0?
1.
1. Correct, because we all know that 10 to the power 0 becomes 1. Anything to the power 0 becomes 1, except if this is 0. 0 to power 0, it's nonsense. It's undefined. But any other numbers to power 0 becomes 1. Then as a result, we get this simplified to this format. 1 equals to x times x plus 8 divided by x plus 18. From there, the root is going to be very easy. I multiply both sides to x plus 18. Then I have x plus 18. And I do expand. From this stage, everything is clear for you because you know that. I expand x into the main argument. Then I end up with what? Then I end up with x squared plus 8x. Correct?
Yes.
Then from there, I just want to make the things look much nicer. What do I mean by it? I mean that in order to do that, I'm just going to write this like that. I keep the x squared. I take x from the left to the right, becomes minus x, plus 8x becomes how much?
7x.
7x. And I have 18 to take it to the right side, becomes minus 18 equal to 0. Correct?
Yes.
And that's there we can stop because we end up with one quadratic function, which we are so good to solve it at this stage. You see, I did from this stage, which I have 2 log equal to each other, I just didn't say these ones are going to be equal. If you followed from that method, you got to the same answer. But if I take the log to the other side minus using another property, another time property number 6, after some simplification, we get up to the same popular quadratic equation, which you can, I should say, you can solve this to see how much is going to be the x. Correct?
Yes.
Guys, any questions? I can explain it more from the beginning or any parts which you didn't understand it correctly. Rose?
No question.
Are you totally fine?
Yes.
Awesome. How about you, Gloria?
No.
Are you sure no questions? Everything is clear for you?
Yes.
Awesome. How about you, Philip?
No.
Everything is fantastic. Everything is clear.
Yes.
And all of you can reproduce the same thing, huh?
Mm-hmm.
Yes? How about you, Ferris? Guys, if you want to rate your learning today from 0 to 100, did you learn these logarithmic functions from 0 to 100 rated? Rose,
Yes.
did you learn it 100%?
Yes.
Philip?
Mm-hmm.
And how about Gloria?
No.
You didn't learn it?
I learned it. I have no questions.
Okay. How about you, Ferris? Ferris? What's happening with the Ferris? Guys, Then I should say thank you very much for, what page number was that? It was page number 7. And this one is going to be page number 8. Guys, then I have to say thank you very much for your participation today. I'm done with the class today. We just reconvene back by 6 p.m. today. Today, essentially, guys, is going to be the very last day. We are not in the classes on Friday because from the next week, we have our regular sessions. Tuesday, Thursday, we have from 11:10 to 1:10. Then this Friday is the only Friday we just catch up with the makeup session. Then I see, if you have no question, guys, I see you back today by 6 p.m. and enjoy your lunchtime then. Okay, guys, see you later if you have no questions.
Bye.
Bye-bye. Bye, everyone. Let me close the page.